So expanding from the previous discussion on search, another strategy or dimension of search is called informed search or heuristic search. We'll soon understand why heuristic, the term heuristic. So an informed or this kind of strategy, which we call informed search strategy, it's one that uses problem-specific knowledge beyond the definition of the problem itself, that makes it able to find solutions efficiently than an uninformed search strategy. So under this informed search strategy, let's look at the best first search. We'll just try to explain so that we get a general understanding of the other category of search which we talk about as far as the design and of our agents are concerned. So the best first search, it's an instance of the general tree search or graph search algorithm in which a node is selected for expansion, but rather than maybe selecting at the same level or going deep first, but here now the node is being selected or for expansion based on an evaluation function. That's the difference. Now we are not just expanding any node following any pattern like from left to right, same lane, or going deeper, further left, that way. But now we are now using a certain evaluation function which we shall term f of n. So the evaluation function is constructed as a cost estimate, so that the node with the lowest evaluation is expanded first. When we say cost estimate, for example, if the example which we've been giving of driving from one city to another, the agent that does that, maybe if time is of important factor, the cost estimate will be based on time, or if it's about distance, it just depends with what are we using as the cost. So but the important thing which makes it different from best first search, depth first search, or uninformed search is that this one now it evaluates the one with the lowest is the one that is expanded. So the choice of f, the function of, determines the strategy. So most best first search algorithms include a component of a heuristic function that is denoted by h of n. So h of n, it's an estimated cost of the cheapest path from the state at the node to a goal of which we are trying to achieve. So you should note that that's why the word heuristic, because the informed search is based on what? On the heuristic. So notice that the h of n takes a node as input, unlike g of n, it depends only on the state at that node. So the node have got more information other than as we described a node before. So I think we understand when we say a node and a state. So this heuristic function now, they give, or they are the most common form in which additional knowledge of the problem is imparted to a search algorithm. So we can use the heuristic function to add more additional knowledge as we desire. That's the concept behind informed search. So this greedy based search, it's a variation of the best first search, but this one now it's more greedy now, how it tries to expand the node that is closest to the goal on the grounds that this is likely to lead to a solution quickly. The way it does it, it's like it's trying to optimize, because as with any search, as with any search, some of those we discuss for instructional so that we understand the concept. But because when you start improving, you should know where you're starting from. So I normally like to start describing from the basic principles. So that's it. It evaluates the nodes by using just a heuristic function that is f of n is equals to h of n. If it finds a solution without ever expanding a node that is not on the solution path, hence the search cost, it becomes minimal, because it doesn't even need to expand a node that is not on the solution if it finds a solution. So we just house there, reducing the costs of the time complexity. But take note is with many algorithms, it is not optimal, since it is greedy. At each step, it tries to get as close to the goal as it can. But now, it can also enter an infinite loop. The greedy best first search tree search is also incomplete, even in a finite state space, much like a depth first search may lead to an infinite loop. The way it expands, it might reach a dead end after disregarding other nodes. So it might end up, even although it will be working on a tree, but it might end up going from the dead end back to the node that leads it there, then back to the dead end, and like that. Then it end up in a finite loop. But there are ways to deal with this. So one more important concept which we just need to touch on whilst we are still on search is optimality. Optimality is trying to optimize or to improve the search, the time complexity. So the concept of pruning, there are a lot we can talk, but the most important one, which we just have to note, is the concept of pruning, eliminating possibilities from consideration without having to examine them. It's important for many areas in artificial intelligence. That is, for example, when we are dealing with a particular agent, and there is quite a number of search tree, and we discover that there are a lot of nodes that are never visited. So we might discard them, we might circle them, seclude them, and prune them off, remaining the most visited nodes. So it becomes it's like we have our algorithm will be now targeting on what just particular set of most relevant nodes. So it's just one concept which can be used to improve our agent. So thanking you, and I hope so far everyone have now a basic understanding that if someone have been doing other modules, like for example Python, using the basic design, with the basic techniques which we've discovered so far, someone is now able to at least try one particular example and implement in their language of understanding. So thanking you very much. Let's meet in the other classes. Thank you.